Now let's explore together how to secure the network from the point of design, how to design a secure network from the beginning. As we can see in this design, and when we say the word design, it is a point of choice. It's something that is optional. I mean that this design we are viewing right now and we are demonstrating right now is not an obligatory design. It's an example design of a secure network. Let's explore it and let's demonstrate the things that makes it secure point by point. Let's see here that we are dividing the network here into some sections. A section that is called the internet, a section on the left that is composed of the servers of the company or the organization that needs to be protected the most, a section on the right that is called DMZ, demilitarized zone servers. This section is a problem for every security specialist because it needs two things that seems to be contradictory. It needs to be published to the internet and it needs to be protected at the same time from the internet. So this is the headache of every security specialist. This section, the DMZ section, it is usually composed of the web, the mail, and the DNS servers and other servers that needs to be published to the internet. Of course, we can see here the router that is connected the whole network to the internet and switches that are composing the local area network of the organization, and the firewall. The firewall is the only security device we have here. We do not yet understand the composition of the firewall and we do not need this at this point, but we will view here the firewall as a security device securing the communication between these sections. That's all, and that's enough for right now. And let's see how this firewall is protecting each of the sections from each other and protecting the whole organization from the internet. The goals of the network design is to publish separate mail, web, and DNS servers to the internet to allow these servers to be published and to be viewed by the internet. These servers to work needs to be viewed by the internet, otherwise it will be useless. So you cannot claim that you have a mail or a web or a DNS server that is completely isolated from the internet through the firewall. It should be published. And another goal is to provide appropriate access for the internal network for your employees, for your internal servers to the internet. And the word appropriate here is the key word. What is the meaning of appropriate? Appropriate means that you can access the resources of the internet and you are not vulnerable to attacks. You are not susceptible to attacks from the wicked people over the internet. You should protect the internal network from external attacks. External attacks can be from the internet, and the attacks also can be internal from other people inside your network that are accidentally, intentionally, or that are wicked enough to attack your resources over the network. Let's see here that we have divided our network into three sections. The public section, which is the internet, which does not lie under my control as a security specialist. The internet is the vector of all the wicked people on the world, and it is the source of all the attacks. I have the semi-public zone, the demilitarized zone, DMZ, which contains the web server, the mail server, the DNS server, and any other server that needs to be published to the internet and at the same time to be protected from the internet attacks. And we have the third section, which is the private internal system, which is composed of the HR servers, the R&D servers, the employees, the people working in the organization, the data, the assets of the company, the workstations, the machines that needs to be connected to the internet, to surfing the internet, to send and receive email, to search the internet on Google or something, and at the same time it is the assets that needs to be preserved and kept and protected from the internet attacks. They need to be exposed to the internet, but not with the same level as the DMZ servers. HR servers and R&D servers needs to be connecting to the internet as surfing or as searching the internet, but not as servers available for the internet, such as the web and the DNS and the mail servers existing in the demilitarized zone. Let's have a look here at the placement of the firewall. The firewall here is placed to protect the sections of the network from each other. It is placed between the internal and the other networks. Let's remember that the internal is the section at the left. The other networks are the section up like the internet and the section right like the DMZ servers. So it is placed between the semi-public, which is the DMZ zone, and the private network, which is the HR and R&D servers. It protects from internet the private systems. It protects the semi-public servers from the private systems. It protects from the semi-public servers to the internet. It protects the internet from the semi-public servers. It protects the communication between each of these sections from the other sections. It protects the traffic from private systems to the internet, the traffic from private systems to the semi-public servers, the traffic from semi-public servers to the internet, and the traffic from the internet to semi-public servers. It protects each of these passes and each of these ways by inspecting the traffic going from here to there and going from here to there, from being malicious or from being a traffic from an attacker. We should here know a concept that is called defense in depth. Defense in depth means that you do not put all your eggs in one basket. You do not diminish or you do not reduce all your protecting devices into one device that is called a firewall, for example. No, you should protect the firewall itself by placing a border router with an access control list. This access control list protects the firewall from the traffic coming from the internet to the internal network. You should limit the visibility of traffic between systems. If one of our systems is compromised, and this is more probable for the systems in the DMZ zone, so you should minimize the consequences as much as possible. You should not allow the compromisation to enter your internal network. It should be blocked by the firewall protecting the traffic coming from the DMZ to the internal network. You should minimize the consequences. You should stop the propagation effect of this attack from being propagated from one of the sections to another, and this is done mainly through the firewall. Let's have a look here at a concept that is the virtual LANs, dividing one physical switch into two or more virtual switches through dividing it into virtual LANs. The VLAN is composed of one or more port inside the switch that is composing VLAN 1, and for VLAN 1 to communicate with VLAN 2, this needs a router to be inside or a layer 3 switch to be between them. So VLANs need some form of routing to tie them together for connectivity. This routing can be done via router or via layer 3 switch. VLANs can span multiple switches. One VLAN can exist on switch 1 and switch 2 and switch 3. And by the same concept, switch 1 can be composed of VLAN 1, VLAN 2, and VLAN 3. Sometimes this is limited by vendor specific switches, so all the switches needs to be Cisco switches or Huawei switches to be composed or to span multiple VLANs across, and sometimes this is not a restriction. Let's have a look at this design. We have here three switches, three physical switches at the left. Each of these switches is composed of three VLANs. One is the marketing VLAN, the other is the sales VLAN, the third is the support VLAN. And at the same time, each of these VLANs exists on the three switches. So if one of the switches is compromised, the VLAN still exists on the other switches. And at the same time, each switch is composed of three VLANs. So we here divided the VLANs according to the functionality of the employees. Marketing employees needs to communicate with each other much more than other employees. So they are placed inside one VLAN. And sales employees the same way. And support employees the same way. Each VLAN is a broadcast domain, so people needs to communicate much with each other are placed on the same VLAN, and people that needs to communicate less with each other are on separate VLANs that must pass through the router to be transferred from a VLAN to another. By this, we have introduced the secure design of a network. Thank you.